Okay, first question. Explain why using vegetable oils as biofuels does not increase global warming. Right, classic exam question. 3 marks, this is what you've got to say. First mark, burning vegetable oils releases CO2 into the environment. Okay, so burning the vegetable oils releases CO2. Right, 1 mark. Second mark, the plants from which the vegetable oil is extracted from, they absorb CO2. So the plants from which the vegetable oil comes from, they absorb or take in CO2. 2 marks. And for the third mark, you just say that there's no net or overall increase in CO2 because the releasing and the taking in balance out. So there's no net increase in CO2. Boom, 3 marks, easy. Just remember that. It often comes up in exams. Okay, next question. Describe how and explain why vegetable oils are hardened for use in foods. Okay, first thing, explain how. Right, so you've just got to memorize this. It's the hydrogenation procedure for vegetable oils, which means you're reacting the vegetable oil with hydrogen. Okay, so say you're reacting with hydrogen. Secondly, you have to mention that there's a nickel catalyst. Okay, and thirdly, you need to remember the temperature. It's 60 degrees C. Okay, 3 marks straight away. This is a 5 mark question, so just saying how, you have to say how and why. Just saying how gets you 3 marks. Okay, so this is hydrogenation conditions. Hydrogen, nickel catalyst, 60 degrees C. Just remember it. Okay, now we have to explain why vegetable oils are hardened for use in foods for the remaining 2 questions. Well, the answer is kind of in the question, or the name. It's hardening. We make them harder. So the first reason why is you can actually make them, to make them harder at room temperature. Room temperature. Or you could say to increase their melting point. The point is that the vegetable oils, before they've been hydrogenated, at room temperature they'd be liquid. So they're hardened in order to make them solid. Yeah, you could say make them solid. That's better than harder. Yeah, don't say harder. To make them solid at room temperature. Yeah, we want them solid at room temperature so we can spread them like margarine. Okay, don't say to turn them into butter. You're not turning them into butter. You're making margarine. Yeah, it's how margarine is made. Okay. And this last reason is an illustration of exam technique yet again. Sometimes if you say what's incredibly obvious, you get the mark. Apparently in this question you get a mark, the 5th mark out of 5, if you just say that they're hardened to remove all the double bonds. Okay, to remove all the double bonds. You might think that, well, yeah, of course, that's obvious. That's what hydrogenation does, but just saying that gets you a mark, okay? You could also say to make them unsaturated. No, to make them saturated, sorry. If there are double bonds, if there are carbon-carbon double bonds, it's unsaturated, okay? Once it's been hydrogenated, all the hydrogens go on where those double bonds are, and there are no longer any double bonds. And that means it's saturated. So hydrogenation saturates the molecule. Okay, let's just draw that out so you know what's going on. If you have some molecule here, the carbon chain might be longer than that. Let's say we've got a carbon-carbon double bond here. So there'll be hydrogens. It's got 3, so room for one more. Carbon has 4 bonds, same with this one. Okay. That would be bonded to another carbon, so would that. Okay, so here's the part of the molecule that we're going to hydrogenate. So you take, this is the vegetable oil molecule, okay, we're going to hydrogenate it, harden it. So we react it with hydrogen. So hydrogen is H2, there's a hydrogen molecule, okay. So we're going to react the vegetable oil with the hydrogen. And like we talked about, this is done under conditions of a nickel catalyst and at 60 degrees C. When the reaction takes place, what happens is that this hydrogen here ends up on that carbon and this one ends up on that carbon. So that bond breaks, right? And that carbon-carbon double bond ends up as a carbon-carbon single bond, right? And 2 new bonds are formed like that. And that's what hydrogenation does. You can see that the original carbon-carbon double bond is gone. The hydrogen's been used up, the hydrogen molecule, the hydrogen, and we've got 2 new bonds here. And that's how the double bond disappears. When all the hydrogens reacted with all of the double bonds in the molecule, then you describe it as saturated. That molecule is now saturated. There are no double bonds left in it. Good, that'll do.